All right, today we're going to crack the code on a topic that, let's be honest, trips up so many of us: one-dimensional kinematics. We're going to forget just staring at a page full of equations. Instead, we're going to build a clear, step-by-step strategy that you can use to solve any of these physics problems with way more confidence.
You know the feeling, right? We've all been there. You read a word problem. It's packed with speeds and times and accelerations, and your mind just goes blank. It's a totally common feeling, but I promise you, there's a systematic way to push right past that initial panic and actually know where to start.
And this quote, this really gets to the heart of it. Success in physics isn't about having every single formula memorized. It's about learning a strategy, a way of thinking that you can apply to pretty much any situation. Now that is some real power.
So here's our game plan for today. We'll start by talking about that physics problem wall. Then we'll assemble our problem-solving toolkit and walk through a solid 6-step game plan. After that, we'll cover the super important reality check, and finally, we'll talk about putting it all into practice. Sound good? Let's dive in.
Okay, first up, the physics problem wall. We're talking about that feeling of being completely and utterly stuck. But you know what? Every wall has a way over it, and today, we're gonna find it.
The way over that wall is to build a toolkit. This lets you see every problem not as some unique, scary monster, but really just as a variation of the same puzzle. The whole key here is moving from just memorizing facts to having a reliable strategy you can count on.
And listen, this is a really crucial mindset shift. Physics isn't just a math class where you plug and chug to get some number. The real goal is a deeper, conceptual understanding. I mean, a numerical solution without any meaning is just, well, it's meaningless. We want to understand the physics behind the numbers.
All right, here it is, the heart of our strategy. This is the 6-step game plan that gives you a reliable structure for every single problem. No more guessing, no more staring at a blank page.
So let's walk through the whole method. Step 1, examine the problem. And seriously, draw a quick sketch to help visualize it. Steps 2 and 3 are so important. You're going to list out your knowns and your unknowns. Then step 4 is finding the equation that links them together. Step 5 is the easy part, just the math. Solve it. And finally, the step that makes all the difference, step 6, check if your answer even makes sense. We're going to really focus in on a few of these.
Let's zoom in on what I think are the most critical steps in this whole process, steps 2 and 3. Honestly, if you can master pulling the knowns and the unknowns out of a tricky word problem, you've already won half the battle, for real. So how do you do it? Well, you basically become a detective. You read the problem carefully, and you make 2 simple lists. For your knowns, you're looking for numbers, yeah? But you're also looking for code words, phrases like starts from rest or comes to a stop. That's physics code for initial velocity is 0 or final velocity is 0. And your unknowns list? That's just what the problem is asking you to find. Just organizing the information this way is a total game changer.
Now for my absolute favorite part, and what I think is the mark of a true physicist, the reality check. After all the math is done, you just have to step back and ask a really simple question. Does this number actually make sense in the real world?
Let's try an example to see what I mean. A runner accelerates at a constant 0.40 meters per second squared for a full 100 seconds. And the question is, what's their final speed? Seems straightforward enough, right? Okay, so we can use a pretty basic equation here. Final velocity equals initial velocity plus acceleration times time. Now, since the runner starts from rest, we know that initial velocity is just 0. So we just multiply acceleration by time. 0.40 times 100. That gives us 40 meters per second. The math checks out. But we are not done yet, not even close.
So you got to ask yourself, is 40 meters per second a reasonable speed for a person who is running? It's kind of hard to get a feel for it in those units, right? To really check our intuition, we need to convert it into something we understand a little better, like miles per hour.
And when you do that quick conversion, you get about 89 miles per hour. Wow, that is literally highway speed for a car.
So I'll ask you, is it reasonable for a human to be running at 89 miles per hour? No, of course not, right? It's physically impossible. And this, right here, brilliantly shows you the power of doing a simple reality check.
And here's the really important takeaway. Our calculation? It was perfect. The equation worked just fine, but the result was impossible. And that tells you something must be wrong with the question itself. The whole idea that a human could accelerate like that for 100 seconds, that's the faulty part.
So this reality check doesn't just catch your own little math mistakes, it actually builds your physical intuition.
So the big question is, how do you get better at this? How do you build that skill and that intuition so it all becomes second nature? Well, it all comes down to one thing: practice.
Here are some active study habits you can start using today. Don't just read the examples in your textbook. Cover them up and actually try to solve them yourself first. Then, get to work on those end-of-section problems. My advice? Start with the easy ones. Build some momentum, build that confidence, and then you can gradually work your way up to the harder challenges.
And just remember, nobody is born a great problem solver. It is a skill. And just like any skill, whether it's playing an instrument or a sport, it gets better with consistent practice. The more problems you solve, the better your creativity and insight are going to become.
So there you have it. You now have the strategy, you have the toolkit, and you have the right mindset to approach these problems. The only thing left to do is to get out there and use it. So what problem are you going to tackle first?